Good afternoon, all of you. Today I am going to present my presentation, Optimize Deep Learning Based Phishing Email Detection using BERT and Hill Climbing Algorithm on the behalf of all the authors of the paper. This is the basic table of content. Firstly, I will give you the brief introduction about the topic, what is phishing, what is consequences. Secondly, I will briefly define about our contribution. Then I will give information about our proposed model, simulation results, and finally I will conclude this presentation. So we can say that phishing attack involves using fake communication, typically email, messages, or websites. So phishing attack is not only limited to messages or a fake emails. Nowadays, hackers create a fake website also, and they send the fake website email link to a specific user. And when user click this link, they can redirect toward the fake website. But in this model, we are mostly focusing on the fake messages. We are mostly focusing on the fake messages and like how it will happen and how our specific fake messages can be detected. And as we can see in this graph, the amount of number of phishing websites are keep on increasing. So we cannot say that phishing is present models are detecting phishing effectively, because every time a hacker create a new method, a new phishing message that can easily fool the new or alternative defined detection methods. So our main aim here in this paper is for the detection of efficient detection method. And now if we think phishing only related to a one domain, but that's not true. Like this graph is showing that phishing, every domain is affected by phishing. Like we can see that education, finance, insurance, even agricultures and energy sectors are also affected by the phishing emails, because hacker generally generate the phishing emails and transmit or pass them to the specific users of a specific domain, like, and then they can hack their personal private information. So phishing is a globalized term which affect all the sectors effectively equally, like 12%, 14%. They are just all the value are same. They are all affected by the same way by the phishing attack. So in this context, this work presents an optimal deep learning method using hill climbing algorithm for hyperparameter optimization and but for feature extraction to improve the phishing detection. In this model, we test our our model by using Kaggle dataset. The model was trained with the balanced precision, recall, and F1 score for phishing and safe email with a 95% of accuracy. So our model with the Kaggle dataset given accuracy of 95%. In terms of decreasing loss and improving generalization, comparative study which is represented by GRU, LSTM, RNN, a logistic regression, and SPM. We compare our model with all these standard deep learning or machine learning models. Prove that whether our model perform efficiently or good or bad in this context. So now I will give you the brief architecture of our model. So this is basically a database, which is in this case it is a Kaggle database. Then a data preprocessing takes place. Means we have to check whether is there any null value present or not, there is a missing value or not, or all the values are integer or not. So sometimes there are some string values are also possible. Then we use a BERT layer. So the main use of BERT layer is for extracting the features from the text, because this data set has two columns. First is the text and second is the labels. Means in text we get the specific email text, and the labels contains 0 and 1. 0 means it is phishing and 1 means it's non-phishing. So it is corrected that. So the BERT main work of BERT is to extract the it will tokenize the text and extract as important features from the text, and then these features are transferred toward the CNN layers. And the work of this CNN layer is to analyze this feature and do the classification. But as we know, we don't know what will be the hyperparameters, like what will the best size, what will be the learning rates, what is the dropout rate. So for the detection of that, we use hill climbing algorithm. By this hill climbing algorithm, we get a specific value of landing date and dropout rate. And these optimal values are fed to CNN layer. And finally, CNN layer do the classification by using these features and the hyper parameter values, which is detected by the hill climbing algorithm. So this is our basic architecture of our proposed model. So first, I will give you information what which system we will use. We use a window-based system, which has CPU capability of physical core of 6 and logical core of 12. And we also use GPU. We use NVIDIA RTX 3050 GPU. We use GPU, so if our speed of performance will increase. And as I previously explained, we use Kaggle data set. We have two our label is divided into 0 and 1, which is a safe email and the phishing email. So we have only two labels in this data set. So this is the data set presentation, and the second phase is the performance of hill climbing algorithm. As this first chart represents the run timing, means for every epoch how much time of hill climbing algorithm we use to generate an optimal values. The, the main aim of hill climbing algorithm that it run for the 100 epochs that is represented by this, and for every epoch it gives some optimal values of the hyper parameters, and then these global hyper parameters are compared with the global hyper parameters, and which one values is gives the most optimal result is get stored in this. And if as we can say that running time is always it is nearly constant, so we can say that it is perform efficiently, so it didn't take much time for a specific generation or a specific epochs. And this is the exploration where the exploitation is how much new things are explore. As we can say, the exploration is keep on decreasing. Means it will get this specifically our saturation value or get a specific value or a constant value which is fixed, or it exploration is increasing, means it explore different results or newer results also. So it will reach towards it converges well, because these values that keep on decreasing, or and again it is also exploring some new results also. The second is the diversity, as diversity also decreases because it represents that model is convergence towards a global value, which is get as constant. It keep on decreasing, and it is a global objective chart. As we can say that we use a loss value, so loss decreases means that value is specifically fixed, and these are the point where a new global objective value is calculated, means it is here. At this point this value is the lowest, then the second lowest, and the third lowest is keep on decreasing. Now the another new value selected. Up to this point this value is minimum, after this value selected, after this value selected, and this is the final global objective value that is finally given by the hill climbing algorithm. And after getting that value, we fed these values to the CNN layer, as I previously explained, and then we use those values to calculate or measure the performance of the CNN layer, which we use classification report to measure the performance. As I previously explained, our data set has two label 0 and label 1. And here we can say that we detect both the levels with 92% and 97%. Also, the recall values are 96% and 95%. F1 score are 94% and 96%. Our all values are more than 95%. Micro average also same. So our model is efficiently working and detecting all the values are more than 95% accuracy. And we also plot the confusion matrix for the better understanding. As these are the safe email, and 1239 times it is detected correctly, but there are some mismatch also, like 110. Although the phishing emails 2103 times it detect correctly, but 56 times it detect a wrong email. So this is not a perfect model, and in future we will try to reduce these values so that we get more efficient result or more accurate values. And this finally, as I previously mentioned, we compare with the standard models and we use loss for the comparison. As we can see that this is this is our proposed model, and its loss value is lowest among all these models. So we can say that our model has very less amount of loss value. So it is more efficient than all these that these standard values, these standard models. So finally, I will put the conclusion of our presentation. So using BERT for feature extraction and hill climbing algorithm for hyperparameter optimization, this work proposed an efficient deep learning based machine email detection method. We use Hackle data set and achieve an efficiency or accuracy of 95%. It performs efficiently regarding the precision, recall, FNS score across safe and phishing emails. We also compared from the standard models, and after comparing from the standard model, we can say that our model is work efficiently and detecting the attacks more efficiently as compared to the standard deep learning or machine learning model. And in future, we will also planning test it on more different type of data set and also try to implement our proposed approach in the real time environment. Thank you.